Alrighty, hi everyone. Before we get into all the math, I just want to start by saying I know that a lot of the topics that we're covering today sound kind of complicated, like rational exponents, complex numbers, polynomial operations, but I promise these aren't impossible. The truth is most of this math is just a bunch of patterns and rules that build off of stuff that we've already learned, so it just looks scarier because the names got longer. So yeah, today I'm basically acting as your fill-in math teacher, and my goal is to explain things in a way that actually makes sense. So it's not just going to be textbook definitions. I'm going to walk us through how to graph linear equations and inequalities, how to write the equation of a line, how to compare different types of functions, and then we'll get into power and roots with rational exponents, and yeah, I'll show you some strategies for solving, give examples that actually make sense, and even talk about how some of this math applies to our real life, because yes, believe it or not, people do use this stuff outside of school. My goal isn't just to throw a bunch of formulas at you, it's to actually help you understand what's going on, so you don't just memorize it, you get it. All right, let's get started. Okay, so we are going to be starting off with graphing linear equations and inequalities. So the strategy is, firstly, we're going to start with the y-intercept, which will be b, and then use the slope m to move up/down and left and right, and plot another point, then connect the line. So here is our example right here. So as an example, we're going to start off with y equals 2x minus 3. So we're going to start at line 0 and negative 3, and the slope is 2, so we're going to go up 2 and right 1. Connect the dots, and we are going to make a solid line on a graph. So I'm going to use Desmos and show you what that might look like. Alrighty, so here I have Desmos pulled up, and I wanted to execute my directions on this platform. So like I said, we're going to start out at 0 and negative 3, which will be about right here, right in the middle of negative 2 and negative 4. And then we remain on the 0 line. So 0 and negative 3 is right here. And then we go up here. And then the second part of my directions were, so the slope was 2, so we are going to go up 2 and right 1. So we have 1, 2, and then we have right 1, which will bring us exactly to the 2, which is exactly where we need to be. So if you are on paper doing this, if you plot these 2 points, what you're going to do is you're going to put a line right through your graph at these 2 points so that everything is all connected and you are all set to go. Okay, so here I'm going to be demonstrating writing the equation of a line. This is about building an equation when you're given information like a graph or 2 points. So for the strategy, step 1 is going to be finding the slope, which is m. And the formula to finding m is y2 minus y1 divided by x2 minus x1. So then step 2 is using y equals mx plus b, which is going to be plugging in 1 point and your slope to solve for b. And then step 3, which is the final step, will be writing the full equation. So for an example, we are given points 2 and 5, and then 4. So here I have comparing functions, and I wanted to talk about how some instances where you'll see that you'll have to compare functions is if you are given a table, graph, or equation and asked which function grows faster, starts higher, or changes more consistently. So here we have linear, exponential, and quadratic. Linear means that there is a constant rate of change. Exponential means multiplying each time, which means that it may grow faster. And then we have quadratic, which changes direction and makes a U-shape. So we're going to take a look at our example, which is a prompt right here that says, one graph rises steadily, another doubles every step. So here we have linear that says that it means that it's a constant rate of change. So as we look at the first sentence, we're going to keep in mind that it says it rises steadily. So but by the equation saying that, or the prompt saying that it rises steadily, it most likely does not mean that it was growing super rapidly, which is exactly what exponential says. It says that it multiplies each time and it tends to grow faster. So I don't believe that steadily aligns with how exponential says grow faster. So we're going to scratch that off as a possible answer for the first graph. But we're going to take a look at quadratic as well. So changes direction and makes a U-shape. So it says that it is rising steadily. So I'm not under the assumption that it is going to change direction or make a U-shape. So our best answer for the first graph is going to be linear. So I'm going to circle linear, and we're going to write it right in here. My handwriting is a little messy, but so then we take a look at the next one. So the next graph is another doubles every step. So when it says double, I don't think that it would change direction and make a U shape. It would most likely mean that we are adding to it, which is exactly the opposite of multiplying. Those go hand in hand with each other. So multiplying each time can also mean doubling, like it mentioned. So I think we can both come to the assumption that the answer that is most likely the right answer will be exponential. So we're going to be writing that in there. Alrighty, and that is it for comparing functions. So now I'm going to be explaining rational exponents and their properties. So here I have a formula, x to the power, and then we have m/n in parentheses equals, in parentheses, n square root x, and then to the power of m. So here we have an example, which is 8 to the power, and then we have in parentheses again 2 and then 3. So this represents this part of the formula. So we want to find this second half of the formula. So first we're going to take the cube root of 8, which is 2, because 3 and square root 8 equals 2. And then we raise the 2 to the power of 2, which equals 4. So 8 to the power, in parentheses, 2 and 3, and then another parentheses equals 4. So this is the second half of the equation, and that is how we solve it. Okay, so now we're going to be looking at polynomial operations, and polynomials are algebraic expressions with multiple terms that you will add, subtract, multiply, and sometimes divide. So let's go through it. So we have all of these, so we're going to be adding and subtracting, multiplying and dividing. So here I have an example, and that example is x plus 2, and then in parentheses x minus 3, and then equals x to the second power minus 3x plus 2 6 minus 6 equals x to the second minus x minus 6. We're going to expand x plus 2 using the distributive property, and I got x to the second minus 3x plus 2x minus 6. So we have x to the second because there's two x's here, and then we're going to put that minus 3 right here, and then we're going to add that 2x, which gives us minus 6 here. And then we're going to look at the middle term, minus 3x and plus 2x. So we have that right here. And then when combining like terms, you'll add or subtract their coefficients. So I went and inputted that right here. And then here we're subtracting the coefficients. And then we have x, and then equals negative 1x equals negative x. So now that we put it together, the final answer that I have is x to the second minus x minus 6. And here we have that here. And then you basically just add, so we have these two x's right here, and then plus that leftover x that we put right here. All right, so to close things out, we've gone over a lot today, and if you stuck with me through all of it, good job. We started with graphing linear equations and inequalities, where the key was understanding slope and y-intercept and how inequalities change the line style and where we shade. And then we covered writing the equation of a line, which really just comes down to finding the slope and solving for the y-intercept using any point. Once you understand that, you can build the equation of any straight line. From there, we looked at comparing functions as well, like graphs, tables, and equations, and figuring out how each one behaves, whether a function has a constant rate like a linear one, or it's growing and multiplying like an exponential. Being able to tell the difference helps you know what kind of pattern that you're dealing with. We also spent time on rational exponents as well and their properties, which might sound a little bit tricky, but it's just another way of writing roots. using fractional exponents. We use the same rules as with regular exponents. Add when multiplying, subtract when dividing, and multiply when raising a power to a power. Then we wrapped up with solving radical equations, where the most important steps are isolating the radical, squaring both sides carefully, and always checking for extraneous solutions. I hope this makes sense. Some of these topics feel more doable because they really are. The more you practice, the more they start to make sense. And if it still feels a little confusing right now, that's okay. What matters most is that you keep showing up and trying to understand it, not just memorizing the steps. Just truly going through each step of the process and really just understanding why certain things happen. And thanks for letting me teach today, and I hope one more thing made sense than it did before, and good luck.